The 3-point bend test is used to measure the force required to bend a beam under 3-point loading conditions. The data is often used to select materials for parts that will support loads without flexing. The test produces tensile stress in the convex side of the specimen and compression stress in the concave side. The test is used to identify stiffness of material when bent. Wearing gloves when handling the beam is recommended to protect against fibre irritation. Safety glasses and goggles are essential during testing. The beam must be weighed before beginning the test. Using a metal rule and pen, the centre of the beam is located and a line is drawn across the width. Digital calipers that have been zeroed are used to measure the width length in millimetres. The thickness of the beam is also measured in millimetres, ensuring the measurement is in the centre of the beam along the marked line. For the calculations, note the span length is 450 millimetres. The beam is placed across the support fixture and the crosshead of the universal testing machine, the instron, holding the centre load point, is lowered to just above the surface. It must not touch the surface of the beam at this stage. The grips are opened and the centre point is gently placed onto the surface of the beam to ensure even contact across the width, and that location is in the centre. On the display screen of the Instron software, tap on the Before Test icon. To zero the load cell figure and the position of the crosshead, tap on the Balance All icon. Enter the measured width and thickness onto the screen. Before beginning the test, ensure safety glasses or goggles are worn, as the safety screen cannot be closed onto this fixture. Tap on the Start icon to begin the test. The graph on screen plots load in newtons on the y-axis against displacement in millimeters on the x-axis, with a constant rate of 6 millimeters per minute compression. While the software is constantly recording the data, because of the resolution of the 30 kilonewton load cell, there is a delay in the visual plot on the graph. This is mitigated by the CSV output file at the end of the test, which lists all the data points not obvious on screen. Failure of the beam is identified on the plot with a sudden fall in load against displacement. The test continues recording data till 12 millimeters of compression is reached, at which point the software will automatically stop. Tap on the return icon, which moves the crosshead back to its starting position. Then remove the beam and make a descriptive note of the fracture. To obtain data from the test, tap on the calculating icon, tap on the results icon and note the maximum load. The raw data must be saved to a USB memory stick, which can be plugged into a port under the screen. The Save icon, Save Sample As, and selecting the keyboard icon at the bottom right-hand side of the screen, type in the group name as the file's label. Save. Tap on the flag icon to export the data. When asked if to start another new sample, tap Yes for the next group to be on the correct window. Minimize the window, double-tap the folder on the desktop labeled Output Shortcut, and locate the CSV data file to be copied. Copy and paste the correct CSV file onto the inserted USB memory stick. Safely eject the memory stick to analyze the data. The data can be opened in Excel, on Windows platforms, or in Numbers on Apple platforms.